Today, we're diving into a fascinating new paper from Stanford University that tackles a huge question for the future of the internet. Can AI agents actually hack and, maybe more importantly, defend the software we use every single day?
Right, this is the big question everyone's trying to answer. We know AI is getting incredible at writing code, but its ability to find flaws, exploit them, or patch them up could completely change the game for cybersecurity. The problem is, we haven't had a good way to measure its real-world skills.
You see, up until now, a lot of the tests for these AIs have been, well, a bit like a sterile lab experiment. They're solving isolated coding puzzles. But that's not how things work out in the wild. Real systems are messy, they're complicated, and they are constantly changing.
So to fix this, the Stanford researchers built something called BountyBench. And this is a whole new way of doing things. It's a testing ground that pits these AI agents against actual software, with real vulnerabilities that people earned real money for finding in bug bounty programs.
And that's actually a great way to think about it. BountyBench is designed to be this standardized, tough but fair challenge that can really tell us what these AIs are made of, both when they're trying to break in and when they're trying to patch things up.
So how does this thing actually work under the hood? Let's peel back the layers and look at the framework, because understanding how they run these tests is key to understanding the results.
The really clever idea here is that software is never finished. It's always a work in progress. So BountyBench treats a system like a timeline of snapshots. Every time a developer pushes new code, that's a new snapshot. And that new code might, introduce a brand new bug, or hopefully fix an old one.
Okay, so this diagram, figure 1 from the paper, shows you the whole pipeline. Let's walk through it. Over on the left, the AI agent gets a task, something like find a vulnerability in this code. Then, in the middle, it gets to interact with the system, that snapshot we just talked about, inside a secure container. It can run commands, look at files, and it gets feedback. It keeps trying things until it thinks it's done. And then the automated evaluator on the right checks its work and says, yep, you did it, or nope, try again.
All right, so BountyBench measures skills across what you could call the entire life of a hack. It gives the AIs 3 very specific jobs to do. Let's break those down. First up is detect. This is the hardest one. Can the AI find a brand new, never-before-seen, zero-day vulnerability with almost no help? Second, exploit. If we give the AI a bug report, basically telling it where the weakness is, can it write an attack that works? And finally, patch. Given that same bug report, can it write the code to fix the problem for good?
Now, this is where it gets really smart, how they automatically judge success. For both finding a new bug and exploiting a known one, the logic is the same. The agent's attack code has to successfully work against the vulnerable version of the software. But, and this is the important part, it has to fail against the patched version. That's the proof that it's targeting the specific bug.
And for the patch task, the bar is even higher. It is not enough for the AI's fix to stop the known attack. The evaluator also runs a whole bunch of other tests to make sure the AI's patch didn't accidentally break some other part of the software. A successful patch fixes the security hole without creating any new problems. That's key. So the researchers took 8 different AI agents from places like OpenAI, Anthropic, and Google and turned them loose on these challenges. So, how did they do? Well, the results were pretty revealing.
The single most surprising result, the big headline, was this really clear imbalance. When you look at the top-performing AI agents, you see a massive gap between how good they are at attacking versus how good they are at defending.
Let's talk defense first. For the patch task, the best agent scored an incredible 90% success rate. Think about that. 9 times out of 10, they could correctly fix a known vulnerability in a complex real-world program. That's amazing.
But when you flip over to the offense side, the story changes completely. The best score for exploiting a vulnerability they were told about, that dropped to 67.5%. And finding a brand new zero-day from scratch, that was incredibly difficult. The top score was only 12.5%.
And this points to another crucial finding from the paper. An agent's success is directly tied to how much information you give it. Now, I know that sounds kind of obvious, right? But what's so cool about BountyBench is that it allowed the researchers to actually measure and quantify this effect.
And you can see that relationship perfectly right here in figure 4 from the paper. On the far left, with no info, that's the zero-day scenario. Success rates are low. But give the AI just a little hint, and performance jumps up. Give it the full bug report, and boom, success rates soar for most of the agents. And I should point out, These weren't some easy, made-up problems. The benchmark was comprehensive. It covered 9 of the OWASP top 10 most critical security risks. We're talking about everything from broken access control to insecure design, making these tests super relevant to the threats companies face every day.
So, what's the big picture here? What does this all mean for the future of cybersecurity? Let's tie it all together with the key takeaways.
So here's the bottom line. AI is not quite ready to be an autonomous super hacker, at least not yet. Finding those novel zero-day bugs is still really, really hard. But it's already a shockingly powerful tool for defense. The ability to automatically patch known flaws is a huge deal. And that means frameworks like BountyBench are absolutely critical so we can keep track of how these skills are evolving and make smart decisions about this tech.
Which leaves us with this final, massive question. Right now, it looks like defense has the upper hand. But what happens as AI gets better and better at both finding bugs and fixing them? Are we headed for a safer internet where vulnerabilities get patched instantly, or a more dangerous one where powerful new attack tools are available to everyone?
Look, if you want to understand complex papers like this one and get right to the core insights without spending days reading them yourself, you are in exactly the right place. We are VibeDoc, and our whole mission is to turn this kind of research into clear, actionable knowledge for you. So if you want to stay ahead of the curve on the technologies that are literally shaping our future, the single most valuable thing you can do is hit that subscribe button right now. Join our community, and let's keep making sense of this complex world together.